This is the Periodic Motion Homework Booklet, question number 1. Figure 1 shows a parcel on the floor of a delivery van that's passing over a humpback bridge on a straight section of road. The radius of curvature of the path of the parcel is r, and the van is travelling at a constant speed v. The mass of the parcel is m. The phrase, the radius of curvature, is a clue for you that you can consider this section of the journey of the van to be circular motion. First of all, draw arrows on the diagram to show the forces acting on the parcel as it passes over the highest point of the bridge. Make sure you label them. So we have the weight of the parcel acting down through the centre of mass of the parcel, and then in the opposite direction we have the normal reaction at the surface where the parcel is sitting on the floor. So both arrows neatly drawn and labelled. Next, you're asked to write down an expression that relates the contact force R between the parcel and the floor of the van to the other variables, including the gravitational field strength. You need to appreciate that the centripetal force is provided by the resultant of the two forces you drew in the previous diagram. So the weight must be greater than the normal reaction so that there is a resultant force equal to the difference between these two, and you equate that to mv squared divided by r, the general equation for centripetal force. Now you might feel tempted to stop at this point, but the mark scheme does carry on, and the clue for that is that you've been asked to relate the contact force R to the other variables. So this suggests that you should rearrange your equation so that R is the subject as shown. Next, you're asked to find the value for R, knowing the values of the other variables. So this is simply substitution into the equation that you've just worked out, and that leads you to an answer of 54.59 newtons. However, it's appropriate to give this to two significant figures. Next, you're asked to explain what would happen to the magnitude of the normal reaction if the van passed over the bridge at a higher speed. You're also asked for the significance of a speed greater than 15 meters per second, and you must support your answer with a calculation. So you need to read this question carefully and make sure that you respond to all of the key points listed. So first of all, what does happen to the magnitude of the normal reaction at higher speeds? So looking at the equation that you had previously, you can see that if the speed is higher, then this part of the equation becomes larger, but mg, the weight, is unchanged, and so the normal reaction will decrease. Next, you want to consider the significance of the value greater than 15 meters per second. So if the speed is high enough, you're going to reach a critical situation where the normal reaction becomes zero. At this speed, the package would lose contact with the floor. So applying that to the previous equation, putting R as 0, will give you that the weight mg is in fact equal to the centripetal force. If you cancel the masses in that equation, you can actually prove that this first occurs, this value of zero normal reaction occurs when the velocity is at 15.02 meters per second. This corresponds with the value given in the question, so that is a relevant calculation. It's actually a very common question to be asked to find the velocity at which something leaves a road or leaves a circular path. Alternatively, the mark scheme did show this method, and this instead uses the value of 15 given and substitutes it into your previous equation and proves that at this point the normal reaction becomes zero. This may not look like zero, but when you consider carefully and compare to the size of the centripetal force, you'll see that it is very much less than that value. Finally, it's worth noting that the mark scheme for this final part, although there are 3 marks that you can achieve in total, they can come from 4 different marking points. We have the first line of this statement, the second line explaining that with reference to this equation, the third line talking about the normal reaction becoming zero, and finally the fourth mark could come from a calculation.